Hey guys, tonight we're going back 66 million years to witness the most famous extinction event in Earth's history. But here's the thing, you're about to discover it wasn't just one catastrophic moment that wiped out the dinosaurs. You're standing in what would become the Yucatan Peninsula, breathing air that's about to become unbreathable, watching creatures that have no idea their 165 million year reign is about to end in the most spectacular way possible. The morning sun rises over a world dominated by giants, Triceratops munching on ferns, Tyrannosaurus rex prowling through forests, and pterosaurs soaring overhead like living nightmares with wings. You probably won't survive what's coming next, but lucky for you, you're just observing from the safety of your bed. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop a comment letting me know where you're watching from and what time it is in your part of the world. I love seeing how this story travels across time zones. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You're witnessing Earth's last normal day, though normal is relative when you're surrounded by animals that would make today's elephants look like house cats. The planet hums with life. Massive herds of Edmontosaurus migrate across plains that stretch beyond the horizon, their thunderous footsteps creating earthquakes you can feel in your bones. Overhead, Quetzalcoatlus, with wingspans reaching 35 feet, cast shadows like flying school buses. It's a world that seems invincible, eternal, unshakable. But you notice something unsettling in the distance, a faint glow on the horizon that doesn't belong to any sunrise. The Deccan traps in what will become India have been spewing poison into the atmosphere for thousands of years, turning sunsets an ominous red, and filling the air with sulfur compounds that make your eyes water. This volcanic activity represents one of the largest eruptions in Earth's history, pumping out lava flows that could cover the entire United States under 500 feet of molten rock. Historians still argue whether these eruptions were the primary cause of the dinosaurs' downfall, or merely set the stage for something worse. You watch a family of Triceratops, adults weighing as much as freight trains, carefully navigate around bubbling tar pits. These creatures have survived ice ages, volcanic winters, and countless smaller extinction events. Their ancestors witnessed the rise and fall of entire ecosystems. Yet, there's something different about this moment. Something that feels like an ending rather than another beginning. The air tastes metallic, charged with an energy that makes your skin crawl. Birds, yes, they're already here, descendants of dinosaurs themselves, seem restless, their usual songs replaced by nervous chatter. Even the insects, those eternal survivors, buzz with unusual urgency. It's as if the entire planet is holding its breath, waiting for something that's been hurtling through space for millions of years to finally arrive. You realize you're not just watching the end of the dinosaurs, you're witnessing the conclusion of the Mesozoic era, a chapter of Earth's story that lasted longer than mammals have existed. The Cretaceous period has been a time of unprecedented diversity, with more dinosaur species than ever before. flowering plants have recently evolved, creating new ecological niches and food webs. Yet this very success might be their downfall. Complex ecosystems are often more fragile than simple ones. As you stand in this ancient world, you can almost feel the weight of deep time pressing down on you. The rocks beneath your feet contain the stories of countless extinctions and recoveries, mass deaths, and explosive diversifications. Earth has been through this before, but never quite like what's coming. The planet is about to experience what scientists call a perfect storm of catastrophes, multiple extinction mechanisms triggering simultaneously, each one amplifying the others, until even the mightiest creatures can't adapt fast enough to survive. The first drops of what will become a months-long rain of death are already falling from the sky, though they're invisible to the naked eye. Cosmic dust, the advance guard of an asteroid the size of Manhattan, begins to enter Earth's atmosphere. You're about to witness the day the Mesozoic era died and the age of mammals began, though that transition will take millions of years to complete and cost the lives of roughly 75% of all species on Earth. You feel it before you see it, a tremor that starts in your bones and spreads outward like ripples in a pond. Except this pond is the entire planet. The morning sky, moments ago painted in gentle pastels, suddenly blazes with an unnatural light that makes you shield your eyes. You're about to witness the Chicxulub impact, the cosmic collision that paleontologists have spent decades studying, and it's nothing like the gentle Hollywood explosions you might imagine. The asteroid, a chunk of rock and metal roughly 6 miles wide, traveling at 45,000 miles per hour, has just punched through Earth's atmosphere like a bullet through paper. In the fraction of a second it takes you to blink, it releases energy equivalent to 10 billion atomic bombs. The impact site, hundreds of miles away, erupts in a fireball that instantly vaporizes everything within a 100-mile radius. You watch in horror as the horizon simply disappears, replaced by a wall of superheated debris racing toward you at the speed of sound. The shockwave hits first, a pressure wave that flattens forests like matchsticks and sends adult triceratops tumbling like toys. Your eardrums would have burst if you weren't observing from the safety of the 21st century. The sound, when it finally reaches you, isn't the sharp crack of thunder, but a deep, rumbling roar that seems to come from the earth itself, as if the planet is screaming in pain. But the real show is just beginning. Within minutes, the sky fills with molten rock, droplets of melted asteroid and Earth's crust, superheated to temperatures that would melt copper. This debris, ejected from the impact site, arcs high into the atmosphere before raining down across the entire planet like a meteor shower from hell. You watch a peaceful herd of Edmontosaurus look up in confusion as the sky begins to glow red, then orange, then white hot. They have no concept of what's happening, no evolutionary experience to draw upon. Their ancestors survived volcanic eruptions and climate changes, but nothing like this. Heat is beyond imagination. Forests that took centuries to grow ignite instantly. the very air becomes a furnace, reaching temperatures that would cook you alive in seconds. You see pterosaurs, those magnificent flying reptiles, plummeting from the sky as their wings literally burn off their bodies. The lucky ones die quickly, others crash to the ground, their ancient instincts telling them to seek shelter that no longer exists. Historians still argue whether the impact winter or the initial heat pulse was more devastating, but you're witnessing both in real time. The immediate aftermath looks like a nuclear war, and a volcanic eruption had a baby and raised it on steroids. Massive tsunamis, triggered by the impact, race across ancient seas at 600 miles per hour, carrying marine reptiles inland and depositing them in what will become fossil beds millions of years later. The geological evidence for this catastrophe is written in a thin layer of clay found in rock formations worldwide, the KPG boundary, as scientists call it. This layer contains iridium, an element rare on Earth, but common in asteroids, concentrations of shocked quartz that only form under extreme pressure, and tiny glass spherules created when rock melts and cools rapidly. It's like Earth's death certificate, preserved in stone. You notice something peculiar. Not all the dinosaurs die immediately. The smaller ones, those roughly the size of chickens, scurry into burrows and crevices, their rapid metabolisms allowing them to survive on minimal food. These will become the birds, the only dinosaurs to survive the apocalypse. Meanwhile, the giants, those magnificent titans that defined the Mesozoic, simply can't adapt quickly enough. A Tyrannosaurus rex needs roughly 400 pounds of meat per day. When the food chain collapses, creatures this size become evolutionary dead ends. The impact has created a crater 110 miles wide and 12 miles deep, though you can't see it through the smoke and debris. The explosion has literally punched a hole in the planet's crust, exposing rock layers that haven't seen sunlight since Earth's formation. The energy released has triggered earthquakes worldwide, some registering magnitude 10 or higher, seismic events that dwarf anything in recorded human history. As the initial fireball subsides, you realize this is just the beginning. The impact has vaporized rock rich in sulfur compounds, creating acid rain that will poison whatever vegetation survives the fires. The debris cloud rising into the atmosphere will block sunlight for months, creating a global winter that will freeze whatever the fire and acid don't kill. You're witnessing the moment Earth's thermostat broke, sending the planet into a climate tailspin that will last for millennia. The once mighty dinosaurs, rulers of land, sea, and sky, are now refugees in their own world. The lucky ones will survive days or weeks. The unlucky ones are already dead. You watch the last T-Rex you'll ever see stumble through the burning landscape, its massive frame silhouetted against the hellish sky, searching for prey that no longer exists in a world that no longer wants them. You pull your imaginary coat tighter as the temperature plummets in ways that would make an ice age look like a tropical vacation. The sky, once blue and welcoming, has transformed into a churning gray ceiling of dust, ash, and vaporized rock that blocks out the sun like a cosmic blindfold. This is the nuclear winter scientists have calculated not from atomic bombs, but from the massive debris cloud created by the Chicxulub impact. The Earth has essentially wrapped itself in a blanket of death. The darkness is absolute. For months, no sunlight penetrates the atmosphere, creating a perpetual twilight that would drive you insane if you weren't already dead from the cold. Temperatures drop by 20 to 30 degrees Fahrenheit globally, turning tropical paradise into frozen wasteland. You watch the last surviving dinosaurs, those magnificent creatures that once basked in Cretaceous warmth, now huddled in whatever shelter they can find, their cold-blooded metabolisms shutting down like engines running out of fuel. The silence is perhaps the most unnerving part. Gone are the thunderous footsteps of sauropods, the roars of predators, the rustling of massive herds moving through forests. Instead, you hear only the whisper of wind through dead trees and the occasional crack of freezing water. The world has become a mausoleum, and you're walking through its halls. Plants, the foundation of every food web, begin dying first. Without sunlight, photosynthesis stops cold, literally. You watch towering conifers, some hundreds of years old, turn brown and brittle in a matter of weeks. The ferns that fed countless herbivores wither and disappear. Flowering plants, those recent evolutionary innovations that had been transforming ecosystems, retreat into dormancy or simply die. The primary producers are gone, and with them, the entire pyramid of life begins to crumble. Herbivorous dinosaurs face an impossible equation. Massive bodies requiring enormous amounts of food in a world where food no longer exists. You observe a group of triceratops, their once mighty bodies now gaunt and desperate, attempting to strip bark from frozen trees with beaks designed for softer vegetation. Their three-horned skulls, evolved for battles with predators, now seem like tragic crowns on dying kings. The carnivores, ironically, might have lasted slightly longer. Initially, there was plenty of carrion. The bodies of impact victims and starving herbivores provided a temporary feast. But even scavengers like Tyrannosaurus rex, despite their fearsome reputation, couldn't survive on decomposing meat indefinitely. You watch the last of these apex predators stumble through the frozen landscape, their massive heads held low, searching for meals that simply don't exist anymore. Historians still argue whether the impact winter lasted 6 months or several years, but from your vantage point, it doesn't matter. Time moves differently when you're dying. Days blur into weeks, weeks into months of endless gray twilight. The planet has become a frozen museum of its former self, preserving the moment when life was abundant in ice and stone. But here's something fascinating. Some creatures actually benefit from this catastrophe. Small mammals, those mouse-sized underdogs of the Mesozoic, suddenly find themselves in a world built for their lifestyle. Their warm-blooded metabolism, small size, and ability to dig burrows become tremendous advantages. They can survive on seeds, insects, and scraps, while the giants starve. You're witnessing the moment when the meek quite literally inherit the earth. Marine ecosystems face their own apocalypse. The oceans, once teeming with massive marine reptiles like Mosasaurus and Plesiosaurs, become graveyards. The lack of sunlight kills off plankton, the microscopic foundation of marine food webs. Without plankton, fish die. Without fish, marine reptiles starve. The seas, which had been relatively stable refuges during previous extinction events, offer no sanctuary this time. The few surviving dinosaurs display behaviors never seen before, desperate adaptations to a world gone mad. Some attempt to migrate to warmer regions that no longer exist. Others try to hibernate, though their physiology was never designed for extended dormancy. You watch a lone ankylosaurus, its armored back scarred by months of foraging through frozen debris, finally collapse beside a frozen stream. Its eyes, once bright with ancient intelligence, dim and go dark. The impact winter is more than just cold and darkness. It's a systematic dismantling of the complex web of relationships that had evolved over millions of years. Pollination stops, seed dispersal ceases, decomposition slows to a crawl. The very processes that had driven evolution for eons come to a grinding halt. Earth becomes a planet in suspended animation, waiting for the sun to return. Yet even in this frozen wasteland, you can see the seeds of recovery. Deep in the soil, beneath layers of snow and ash, some plant roots remain alive. In protected valleys, small populations of hardy species wait out the winter. The planet is down, but not out, though it will take millions of years to recover the biological diversity that was lost in mere months. You find yourself transported to the western coast of ancient India, where the earth is literally turning itself inside out. The Deccan Traps, a name that sounds deceptively peaceful, represent one of the largest volcanic eruptions in Earth's history, and you're witnessing a slow-motion apocalypse that makes the asteroid impact look like a firecracker. These aren't the cone-shaped volcanoes you might imagine. Instead, you're watching massive fissures in the ground spew lava like planetary arteries bleeding molten rock. Eruptions have been going on for thousands of years before the asteroid even arrives, gradually poisoning the atmosphere with sulfur dioxide, carbon dioxide, and other volcanic gases. You can taste the metallic tang in the air, feel your throat burn with each breath. The sky glows an unnatural red, tinted by volcanic ash that has been circulating in the atmosphere for decades. This is environmental warfare on a geological scale, and the dinosaurs have been slowly losing the battle for millennia. The sheer scale of these eruptions defies comprehension. You watch lava flows that stretch for hundreds of miles, creating step-like formations called traps that will eventually cover an area larger than France with molten rock, up to 6,000 feet thick. The heat radiating from these flows would melt your skin from miles away. Yet, this isn't just about local destruction. The volcanic gases are fundamentally altering Earth's climate and chemistry. Sulfur dioxide from the eruptions creates acid rain that falls across the globe, turning precipitation into a corrosive agent that strips leaves from trees and dissolves the shells of marine creatures. You observe a group of sauropods, those gentle giants whose long necks once reached the highest tree branches, now struggling to find vegetation that hasn't been poisoned by volcanic fallout. Their massive bodies, evolved for processing enormous quantities of plant matter, become liabilities in a world where plants are increasingly toxic. The carbon dioxide emissions create a greenhouse effect that makes the climate violently unstable. Temperatures swing wildly between scorching heat and bitter cold, sometimes within the same season. You watch herds of hadrosaurs, those duck-billed dinosaurs with complex social structures, break apart as migration routes become unpredictable. Their evolved behaviors, refined over millions of years, suddenly become maladaptive in a world where the rules keep changing. Historians still argue whether the Deccan traps were the primary cause of the dinosaurs' extinction, or merely weakened them before the asteroid delivered the final blow. From your perspective, watching these magnificent creatures struggle against an invisible enemy, the distinction seems academic. The volcanism is already doing what the asteroid will later accomplish, systematically dismantling the ecological networks that support large-bodied life. Marine ecosystems face their own volcanic hell. The oceans absorb massive amounts of carbon dioxide, becoming more acidic and depleting oxygen levels. You witness ammonites, those spiral-shelled masters of the ancient seas, struggling in waters that can no longer support their calcium carbonate shells. Their intricate chambers, evolutionary marvels that had allowed them to control buoyancy for millions of years, begin to dissolve in the acidic water. But here's where it gets really interesting. The volcanic emissions aren't just killing, they're also creating new evolutionary pressures. Some plant species begin developing resistance to acid rain, while others evolve to cope with the unstable climate. You're watching evolution in fast forward, species adapting or dying in real time. The mammals, with their adaptable physiology and smaller energy requirements, handle these changes better than the dinosaurs' more specialized systems. Volcanic winter periods, when massive ash clouds block sunlight, create rehearsals for the impact winter to come. Plants die back, food webs collapse, and the largest dinosaurs starve. But unlike the asteroid impact, these volcanic winters are followed by periods of intense greenhouse warming as the ash settles and carbon dioxide levels spike. The dinosaurs must adapt to both extremes, and their specialized body plans make this increasingly difficult. You observe the social breakdown of dinosaur communities under volcanic stress. Herds that once moved in coordinated migrations now scatter in confusion as traditional food sources disappear. Nesting sites, used for generations, become uninhabitable due to toxic ash fall. The complex behaviors that had made dinosaurs such successful species, their sophisticated communication, elaborate mating displays, and cooperative hunting strategies, begin to unravel as environmental chaos overwhelms their ability to adapt. The volcanism also triggers what scientists call hypercanes, hurricanes so powerful they reach into the stratosphere, spreading volcanic ash and gases globally. You watch these monster storms, with wind speeds exceeding 300 mph, devastate whatever ecosystems have managed to survive the direct volcanic effects. The planet's weather system becomes a weapon against its own inhabitants. As you stand in this hellscape of fire and poison, you realize the Deccan traps represent something more insidious than the asteroid impact. While the asteroid kills quickly, the volcanism kills slowly, relentlessly, giving its victims just enough hope to continue suffering. The dinosaurs aren't just dying, they're being tortured to death by their own planet, weakened and demoralized before the final blow arrives from space. You're breathing air that would kill you in minutes, though you don't realize it yet. The atmosphere around you contains a cocktail of toxins that would make a modern chemical weapons factory look like a health spa. Carbon dioxide levels have spiked to concentrations that cause hypercapnia, literally carbon dioxide poisoning, in large animals. You watch a magnificent Alamosaurus, a sauropod the size of a city bus, stumble and collapse, not from injury or starvation, but from the simple act of breathing air that has become hostile to life itself. The planet's atmospheric chemistry is fundamentally broken. Volcanic eruptions have been pumping out hydrogen sulfide, sulfur dioxide, and other toxic gases for millennia, while the asteroid impact has added vaporized rock and metal to the mix. You can see the effects in the vegetation, leaves yellowing and dropping, not from seasonal change, but from chemical burns. The very air that once supported the largest land animals in Earth's history has become their enemy. Mercury levels in the environment have skyrocketed beyond anything seen in natural systems. This heavy metal, released by volcanic activity and asteroid impacts, accumulates in the food chain like a slow-acting poison. You observe a pack of Deinonychus, those intelligent raptors with their distinctive sickle claws, moving with uncharacteristic clumsiness. Their nervous systems, poisoned by mercury bioaccumulation, no longer coordinate their legendary precision. These apex predators, evolved to be killing machines, now struggle to catch prey that would have been easy meals just months earlier. The water systems tell an even more disturbing story. Rivers and lakes that once ran clear now flow with acidic runoff that can dissolve bone. You watch a group of Parasaurolophus, those duck-billed dinosaurs famous for their musical calls, approach a seemingly pristine lake. Their elaborate head crests, designed to produce complex social sounds, emit only weak, distorted calls, their respiratory systems damaged by months of breathing toxic air. When they drink, the acidic water burns their throats and digestive systems, adding injury to the insult of their poisoned environment. The soil itself has become toxic. Volcanic ash has deposited heavy metals and acidic compounds that kill root systems and prevent new plant growth. You witness the slow death of forests that took centuries to grow, their root systems literally dissolved by the chemically altered earth. The Cretaceous period's lush vegetation, which had supported massive herbivore populations, transforms into a barren wasteland where only the most acid-tolerant plants can survive. Historians still argue whether chemical poisoning was a primary extinction mechanism or merely a contributing factor. But from your vantage point, the distinction is meaningless. You're watching environmental contamination on a scale that makes modern pollution look trivial. The planet has become a giant chemistry experiment gone wrong, and the dinosaurs are unwilling test subjects. Toxic atmosphere affects different species in different ways, creating a hierarchy of suffering. Flying reptiles like pteranodon, with their lightweight bones and large lung capacity, succumb quickly to respiratory failure. You watch these magnificent creatures, masters of the ancient skies, spiral down from the heavens as their lungs fill with fluid, and their hollow bones become too fragile to support flight. Their bodies, perfectly adapted for soaring on Cretaceous thermals, become death traps in toxic air. Marine reptiles face their own chemical hell. The oceans, once refuges from terrestrial catastrophes, now contain dissolved metals and acids that attack shell-forming organisms. You observe a Mosasaurus, a marine lizard the size of a modern whale, writhing in agony as the acidic water burns its skin and eyes. These apex predators of ancient seas, with no evolutionary experience of chemical warfare, have no defense against an enemy they cannot see or understand. The smaller dinosaurs, those that might have survived the initial catastrophes, now face death by 1,000 cuts. Heavy metal poisoning causes neurological damage, making them easy prey for the few remaining predators. Their elaborate courtship displays, refined over millions of years of evolution, become erratic and unsuccessful as brain damage impairs their ability to recognize mates and perform complex behaviors. You notice something particularly cruel about this slow poisoning. It affects intelligence first. The smartest dinosaurs, those with the largest brains and most complex behaviors, suffer the most severe neurological damage. Troodon, possibly the most intelligent dinosaur, loses its problem-solving abilities and becomes confused, unable to adapt to changing conditions. The very intelligence that made these creatures successful becomes a liability as their damaged brains misinterpret environmental cues. The food web collapses not just from lack of food, but from the food itself becoming poisonous. Plants that do manage to grow in the toxic soil concentrate heavy metals and acids in their tissues. Herbivores that eat these plants suffer organ damage and reproductive failure. Carnivores that eat the herbivores receive concentrated doses of toxins that cause liver failure and neurological disorders. The entire ecosystem becomes a pyramid of poison, with each level more toxic than the last. As you watch this slow-motion apocalypse unfold, you realize that the dinosaurs aren't just dying. They're being systematically poisoned by their own planet. The chemical legacy of the Deccan traps and Chicxulub impact will persist for thousands of years, ensuring that even if some dinosaurs survive the initial catastrophes, their descendants will inherit a world hostile to large-bodied life. The Earth has become a toxic wasteland, and the age of giants is ending not with a bang, but with a slow, chemical whimper. You're standing on what used to be the bottom of an ancient sea, watching the last marine reptiles of the Mesozoic era literally stranded by a planet that's changing faster than they can adapt. The global sea level has dropped by over 200 feet, exposing vast continental shelves and transforming shallow tropical seas into dry land. You witness Mosasaurus, those massive marine lizards that once ruled the ancient oceans, now trapped in shrinking lagoons and inland seas, their 50-foot bodies thrashing helplessly as their aquatic world disappears beneath them. The Western Interior Seaway, once a vast ocean that split North America in half, has become a series of disconnected lakes and rivers. You watch Hesperornis, those toothed diving birds perfectly adapted for marine life, struggling in freshwater environments that their physiology was never designed to handle. Their specialized kidneys, evolved to process salt water, fail in the diluted conditions of these new freshwater systems. These magnificent swimmers, essentially aquatic dinosaurs, find themselves as out of place as whales in a desert. The retreat of the seas has exposed millions of square miles of muddy seafloor, creating new land bridges and barriers that fundamentally alter migration patterns. You observe herds of triceratops that once moved freely across ancient archipelagos, now trapped on shrinking islands of suitable habitat. Their traditional migration routes, encoded in genetic memory over millions of years, suddenly lead to dead ends or impassable barriers. The continental geography that shaped their evolution has been rewritten in geological moments. This massive regression isn't just about water levels, it's about the complete reorganization of global climate patterns. The warm, humid conditions that characterized the Cretaceous period depended on vast, shallow seas that moderated temperature extremes. With these thermal buffers gone, you witness the beginning of more extreme seasonal variations. The gentle, stable climate that allowed massive, cold-blooded reptiles to thrive becomes a relic of the past. The marine food webs, already stressed by toxic conditions, completely collapse as their physical habitat disappears. You watch the last ammonites, those spiral-shelled mollusks that had survived multiple previous extinction events, struggle in increasingly shallow and polluted waters. Their complex life cycles, which relied on specific depth zones and water conditions, become impossible to complete. These creatures, masters of neutral buoyancy and jet propulsion, find themselves in a world where their evolutionary perfection becomes evolutionary obsolescence. Historians still argue whether the sea level regression was primarily caused by volcanic activity changing ocean basin volumes, or by climate change affecting water storage. But the result is the same, a fundamental restructuring of Earth's surface. You're witnessing the moment when the planet's blueprint changed, creating new continents and destroying others, isolating populations and creating evolutionary dead ends. The newly exposed land creates vast deserts where lush coastal plains once existed. You observe Saltosaurus, those armored sauropods adapted for specific vegetation types, wandering through landscapes that no longer support the plants they evolved to eat. Their massive digestive systems, designed to process particular types of flora, become useless in these new environments. The highly specialized nature of late Cretaceous ecosystems once an advantage, becomes a fatal liability. Continental drift adds another layer of complexity to this geographic chaos. The breakup of Gondwana has been gradually isolating dinosaur populations on different continents, reducing gene flow and creating endemic species with limited adaptability. You watch Madagascar separating from the African mainland, taking with it unique dinosaur populations that become evolutionary islands, magnificent but doomed experiments in isolation. The coastal wetlands, nurseries for countless species, drain away like bathtubs with the plugs pulled. You witness the collapse of nesting sites that had been used for millions of years. Maiasaura, those good mother lizards famous for their elaborate parental care, find their traditional nesting grounds transformed into arid flats, unsuitable for egg incubation. Their sophisticated behavioral adaptations, including temperature-controlled nests and communal child-rearing, become impossible to maintain. The changing geography affects predator-prey relationships in ways that cascade through entire ecosystems. Natural barriers that once protected herbivore populations disappear, while new obstacles fragment hunting territories. You observe Albertosaurus, those pack-hunting tyrannosaurs, losing their cooperative hunting strategies as their territorial boundaries become meaningless in the face of radical landscape changes. Rivers change course as the continental drainage patterns shift, creating new wetlands in some areas while destroying others. You watch Spinosaurus, those semi-aquatic fish-eating dinosaurs, stranded in regions where the rivers they depend on have either dried up or changed course. Their specialized anatomy, elongated skulls, dense bones for diving, and powerful swimming tails becomes a burden rather than an advantage in this new geography. Most insidious aspect of this geographic transformation is its permanence. Unlike volcanic eruptions or asteroid impacts, which cause temporary disruption followed by recovery, the sea level regression and continental drift create permanent changes that require completely new evolutionary strategies. The dinosaurs, with their specialized body plans and narrow ecological niches, lack the flexibility to adapt to these fundamental changes in Earth structure. As you survey this transformed landscape, you realize you're witnessing more than just habitat loss. You're seeing the moment when Earth's surface became hostile to the body plans that had dominated for over 160 million years. The planet that created the dinosaurs has become the planet that will destroy them, not through violence, but through the simple act of changing the rules of the game. You're witnessing one of the most beautiful revolutions in Earth's history, and it's killing the dinosaurs with petals and pollen. The rise of flowering plants, angiosperms, represents a fundamental shift in terrestrial ecosystems that's as dramatic as any asteroid impact, just slower and more seductive. You watch a world transforming from the familiar ferns and conifers of the Mesozoic into something entirely new. A landscape dominated by flowers, fruits, and complex plant-animal relationships that the dinosaurs simply cannot navigate. The first flowers appeared roughly 130 million years ago, but by the late Cretaceous, they're everywhere. You observe vast meadows of primitive roses, magnolias, and water lilies, creating new ecological niches that didn't exist when the dinosaurs' ancestors first evolved. These aren't just pretty decorations, they're revolutionary technologies that change how energy flows through ecosystems. The concentrated nutrition of fruits and seeds, the complex chemical defenses of flowering plants, and the intricate relationships with pollinators create a web of interactions that the dinosaurs never learned to exploit. Herbivorous dinosaurs, with their massive digestive systems optimized for processing tough, fibrous vegetation, suddenly find themselves in a world where the most nutritious food sources are locked away in forms they cannot access. You watch a group of triceratops attempting to eat flowering shrubs, their powerful beaks designed for stripping pine needles and fern fronds struggling with the small, delicate structures of angiosperm leaves. Their digestive systems, evolved over millions of years to break down cellulose-heavy gymnosperms, cannot efficiently process the different chemical compounds found in flowering plants. But here's the really insidious part. The flowering plants aren't just changing what's available to eat. They're changing how ecosystems function. Flowers create new seasonal patterns of resource availability, with concentrated bursts of nectar and pollen, followed by periods of scarcity. You witness the dinosaurs' food web becoming increasingly unpredictable as plants shift their energy investment from continuous growth to seasonal reproduction. The steady, reliable food sources that supported massive herbivore populations become boom and bust cycles that favor smaller, more adaptable animals. The coevolution between flowering plants and insects creates another layer of complexity that works against the dinosaurs. You observe the explosion of butterfly and bee diversity, creating new pollination networks that bypass the dinosaurs entirely. These insects, with their rapid generation times and behavioral flexibility, form partnerships with flowering plants that revolutionize terrestrial ecosystems. The dinosaurs, with their slower metabolisms and less flexible behaviors, become evolutionary bystanders in this new world of wings and petals. Historians still argue whether the flowering plant revolution was a primary cause of dinosaur extinction or merely a contributing factor. But from your perspective, watching these magnificent creatures struggle with a world that no longer makes sense to them, the distinction is academic. The very success of flowering plants creates new types of ecological instability that the dinosaurs cannot handle. The chemical warfare between plants and herbivores reaches new levels of sophistication with flowering plants. You watch as primitive roses and other angiosperms develop complex alkaloids and other defensive compounds that the dinosaurs have no evolutionary experience with. Their detoxification systems, evolved to handle the relatively simple chemical defenses of ferns and conifers, cannot cope with the sophisticated chemical arsenal of flowering plants. You observe a group of Edmontosaurus, those successful duck-billed dinosaurs, becoming increasingly ill after feeding on what appears to be harmless flowering vegetation. Their bodies simply cannot process the novel toxins. The seed dispersal strategies of flowering plants create another evolutionary puzzle that the dinosaurs cannot solve. Unlike the wind-dispersed seeds of conifers or the simple spores of ferns, many flowering plants develop fruits designed to be eaten by specific animals. You watch small mammals and early birds monopolizing these nutritious food sources, their body size and digestive systems perfectly matched to the plant's reproductive strategies. The dinosaurs, with their massive bodies and indiscriminate feeding habits, either cannot access these resources or damage them without providing the dispersal services the plants require. The seasonal nature of flowering plant reproduction creates what ecologists call temporal mismatches in the food web. You observe dinosaur species that had evolved to time their breeding cycles with the steady growth patterns of ancient plants now finding themselves out of sync with the boom and bust cycles of flowering plants. A female Maiasaura might lay her eggs, expecting abundant vegetation to feed her hatchlings, only to find that the flowering plants have shifted their energy to reproduction rather than growth. The rise of grasses, though still in its early stages, represents another challenge for large herbivores. You watch the first primitive grasslands appearing in disturbed areas, creating new fire regimes and grazing pressures that the dinosaurs cannot adapt to. These grasses, with their ability to regrow from their base rather than their tips, favor smaller, more selective browsers over the massive, indiscriminate feeding strategies of sauropods and ceratopsians. The pollination networks created by flowering plants and insects establish new baseline energy flows in ecosystems that exclude the dinosaurs entirely. You observe vast amounts of energy being channeled through flower-to-insect relationships, creating productive ecosystems that the dinosaurs cannot tap into. The nectar and pollen that fuel these new food webs are locked away from animals that lack the behavioral sophistication to access them. Forest structure changes dramatically with the rise of flowering trees. You watch the open, cathedral-like conifer forests of the early Cretaceous being replaced by dense, multi-layered angiosperm forests with complex understories. These new forest types favor smaller, more agile animals that can navigate the intricate branch networks and varying light conditions. The massive dinosaurs, evolved for open woodlands and plains, find themselves increasingly confined to shrinking habitats that match their locomotory abilities. The most tragic aspect of this botanical revolution is its beauty. You're watching the dinosaurs die in the most gorgeous mass extinction in Earth's history, surrounded by the first roses, the first water lilies, the first fruit trees. The world is becoming more beautiful, more complex, more sophisticated, and less suitable for the giants that once ruled it. The flowering plants represent the future of terrestrial ecosystems, and that future has no place for creatures the size of buses. As you stand in this transformed landscape, breathing air perfumed with the scent of the first flowers, you realize that evolution isn't always about survival of the fittest. Sometimes it's about survival of the most adaptable to change. The dinosaurs, masters of their world for over 160 million years, are being defeated not by violence or catastrophe, but by beauty, complexity, and the simple fact that life has moved beyond the ecological strategies that made them successful. You're witnessing microscopic warfare on a planetary scale, where the smallest organisms are bringing down the largest creatures in Earth's history. The stress of environmental catastrophe has compromised the immune systems of every dinosaur species, turning their bodies into breeding grounds for pathogens that would normally be manageable nuisances. You watch a once mighty ankylosaurus, its armored back scarred from months of environmental stress, stumbling through a landscape where every breath brings new infectious agents into its weakened respiratory system. The fungal outbreaks are particularly devastating. You observe vast die-offs of vegetation caused by aggressive fungal diseases that thrive in the humid, toxic atmosphere created by volcanic activity and impact debris. But these plant pathogens are just the beginning. Fungal spores fill the air like biological weapons, attacking the respiratory systems of animals already weakened by malnutrition and chemical exposure. The dinosaurs, with their large lung capacity and constant need for oxygen, become particularly vulnerable to these airborne infections. Parasitic diseases that had been kept in check by healthy immune systems now run rampant through dinosaur populations. You watch a herd of Parasaurolophus, those musical duck-billed dinosaurs, suffering from massive intestinal parasite loads that prevent them from absorbing nutrients from what little food they can find. Their elaborate head crests, normally used for complex social communication, now emit only weak, distorted calls as malnutrition and disease ravage their bodies. The very social behaviors that made them successful, living in large herds for protection, now facilitate the rapid spread of contagious diseases. The bacterial infections are perhaps the most insidious. You observe wounds that would have healed quickly in healthy dinosaurs becoming septic death sentences in the compromised conditions of the post-impact world. A Tyrannosaurus rex with a minor bite wound from a struggle with prey finds itself dying not from the injury itself, but from the bacterial infection that spreads through its bloodstream. These apex predators, evolved to survive violent encounters with other large predators, are being killed by microscopic organisms they cannot even see. Historians still argue whether disease was a primary extinction mechanism or merely a contributing factor. But from your perspective, watching these magnificent creatures waste away from invisible enemies, the academic distinction is meaningless. You're witnessing biological warfare on a scale that makes human pandemics look like minor inconveniences. The dinosaurs are fighting a war they cannot win against enemies they cannot even perceive. The vector-borne diseases create cascading effects through the food web. You watch as blood-sucking insects, thriving in the warm, humid conditions created by environmental chaos, spread viral and bacterial infections between species at unprecedented rates. A disease that starts in herbivorous dinosaurs quickly spreads to their predators, creating creating epidemic conditions that collapse entire local ecosystems. The intricate predator-prey relationships that had evolved over millions of years disintegrate under the pressure of widespread disease. The most devastating aspect of this biological catastrophe is how it interacts with other extinction pressures. You observe dinosaurs that might have survived the climate changes or food shortages if they were healthy, but the combination of disease and environmental stress creates lethal synergies. A triceratops with a respiratory infection cannot effectively process the limited vegetation available, while a Edmontosaurus with intestinal parasites cannot build up the fat reserves needed to survive the nuclear winter conditions. Reproductive failure becomes widespread as sexually transmitted diseases and general poor health combine to crash birth rates. You watch elaborate dinosaur courtship rituals failing as potential mates recognize the signs of disease and avoid infected individuals. The complex social structures that had evolved to ensure successful reproduction, from the bower-building behaviors of small theropods to the massive territorial displays of ceratopsians, break down as disease makes normal social interactions dangerous. The marine reptiles face their own disease apocalypse. You observe die-offs of marine organisms, creating massive algal blooms and bacterial growth that poison the water with toxins. Mosasaurus and other marine reptiles, already stressed by acidic oceans and reduced food supplies, find themselves swimming through water that has become a liquid culture medium for deadly pathogens. Their specialized marine physiology, evolved over millions of years, provides no defense against the novel combination of toxins and diseases. The psychological effects of widespread disease add another layer of suffering. You watch intelligent dinosaurs like Troodon displaying behaviors that suggest awareness of their own mortality, avoiding sick individuals, abandoning traditional territories, and engaging in desperate behaviors that suggest panic. The social bonds that had sustained dinosaur communities for millions of years fray under the pressure of constant death and disease. The final cruel irony is that the very adaptations that made dinosaurs successful become vulnerabilities in the face of pandemic disease. Their large body size, which provided advantages in thermoregulation and predator avoidance, makes them easier targets for parasites and harder to maintain when sick. Their complex social behaviors, which had been evolutionary advantages, become disease transmission networks that spread pathogens faster than immune systems can respond. As you watch this biological catastrophe unfold, you realize that the dinosaurs aren't just dying from disease, they're dying from the collapse of the biological relationships that had sustained them for over 160 million years. The microscopic world that had co-evolved with them has turned against them. And in a world where every other survival pressure is also maximized, there's no evolutionary strategy that can save them from enemies they cannot fight. You're witnessing the ultimate evolutionary upset, where the underdogs of the Mesozoic are finally getting their chance to shine, while the former champions struggle to compete. mammals, those mouse-sized survivors that had spent 160 million years living in the shadows of dinosaurs, are suddenly finding themselves in a world built for their lifestyle. You watch a group of early primates, no bigger than squirrels, efficiently harvesting seeds and insects, while a massive Edmontosaurus nearby slowly starves, unable to compete for the limited high-quality food sources. The competition isn't just about food, it's about ecological space itself. You observe small mammals moving into burrows and tree hollows, occupying three-dimensional habitat niches that the dinosaurs simply cannot access. While a triceratops requires acres of open space to support its massive body, a mammal the size of a rat can thrive in a space no larger than a closet. The post-catastrophe world, fragmented and resource-poor, favors animals that can make do with small territories and flexible diets. The birds, those direct descendants of dinosaurs, are competing with their own relatives and winning. You watch early ducks and shorebirds efficiently harvesting aquatic resources, while large marine reptiles struggle in the increasingly shallow and polluted waters. The birds' smaller size, faster metabolisms, and behavioral flexibility allow them to exploit seasonal resources and adapt to changing conditions in ways that their giant cousins cannot match. It's a cruel irony that the most successful survivors of the dinosaur lineage are the ones that abandoned the body plans that had made dinosaurs dominant. The energy economics of survival heavily favor the small competitors. You observe a fascinating calculation playing out in real time. A single Tyrannosaurus rex requires the equivalent caloric intake of hundreds of small mammals. But in a world where food is scarce, those hundreds of small mammals are more likely to find enough sustenance to survive. The dinosaurs' massive body size, once their greatest advantage, becomes an insurmountable liability in an energy-starved world. The behavioral advantages of the competitors become increasingly apparent. You watch mammals displaying learning behaviors and problem-solving abilities that allow them to exploit new food sources and adapt to changing conditions. A group of early carnivorous mammals discovers how to crack open dinosaur eggs, turning the reproductive efforts of their giant competitors into their own survival advantage. Their behavioral flexibility, evolved during millions of years of avoiding dinosaur predators, now helps them outcompete the dinosaurs themselves. Historians still argue whether competition from mammals and birds was a primary cause of dinosaur extinction, or merely an opportunistic exploitation of dinosaur decline. But from your perspective, watching these interactions play out, the distinction is meaningless. You're witnessing the moment when the meek quite literally inherit the earth, not through divine intervention, but through superior adaptation to catastrophic conditions. The nesting site competition becomes particularly intense. You observe mammals and birds taking over traditional dinosaur nesting areas, either by directly competing for the physical space or by consuming dinosaur eggs and hatchlings. The elaborate parental care behaviors that had given dinosaurs reproductive advantages From the communal nesting of Maiasaura to the protective behaviors of Orodromius, become liabilities when the nest sites themselves are under constant assault from smaller, more numerous competitors. The social structures that had sustained dinosaur communities begin to fragment under competitive pressure. You watch a pack of Deinonychus, those intelligent raptors that had been apex predators, losing their coordination as individual members compete desperately for limited resources. Their sophisticated pack hunting behaviors, evolved over millions of years, break down when there simply isn't enough prey to share. The social bonds that had made them successful become sources of internal conflict. The pollination networks that had excluded dinosaurs from flowering plant ecosystems now actively benefit their competitors. You observe the mutualistic relationships between early birds and flowering plants, creating exclusive resource networks that mammals and birds can access, but dinosaurs cannot. The dinosaurs find themselves locked out of the most productive food webs in their own world, reduced to scavenging the scraps of ecosystems they no longer have the evolutionary keys to unlock. The most insidious aspect of this competition is its cumulative effect. You watch dinosaurs that might have survived one or two competitive pressures succumbing to the overwhelming combination of challenges from multiple directions. An Ankylosaurus might defend its territory against a single mammalian competitor, but it cannot defend against dozens of different species, all exploiting slightly different aspects of its ecological niche. The reproductive competition is perhaps the most devastating. You observe mammals and birds not just competing for the same food sources as dinosaurs, but actively consuming dinosaur eggs and hatchlings. The long generation times of dinosaurs, once an advantage that allowed for complex development and large body size, become a fatal disadvantage when their offspring become food for rapidly reproducing competitors. A single mammalian female can produce multiple litters in the time it takes a dinosaur to raise a single clutch of young. The climax of this competitive exclusion comes when you realize the competitors aren't just taking advantage of dinosaur weakness, they're actively contributing to it. Every seed consumed by a mammal instead of a dinosaur, every insect caught by a bird instead of a small theropod, every burrow occupied by a mammal instead of a dinosaur, represents a small victory that accumulates into evolutionary dominance. The dinosaurs are being defeated not by dramatic predation or direct conflict, but by the relentless pressure of superior efficiency in a resource-limited world. As you watch this great competitive shift unfold, you realize you're witnessing more than just species replacement. You're seeing the moment when the fundamental rules of terrestrial ecosystems changed forever. The age of giants is ending not with a bang, but with the quiet efficiency of small creatures doing what they do best: surviving, reproducing, and adapting to change faster than their larger competitors can respond. You're witnessing evolution's cruelest trap, where the very success of the dinosaurs has become their doom. The massive populations of Triceratops, Edmontosaurus, and other late Cretaceous giants have created an illusion of genetic health, beneath the surface, millions of years of specialized evolution have painted these magnificent creatures into evolutionary corners from which there is no escape. You watch a herd of triceratops, thousands of individuals that look identical to the untrained eye, struggling with a genetic uniformity that makes them sitting ducks for any environmental change. The problem isn't just small population sizes due to the current crisis. It's the legacy of evolutionary specialization that has stripped away the genetic flexibility needed for rapid adaptation. You observe the skull of a triceratops, that magnificent three-horned wonder of evolution, and realize you're looking at a masterpiece of genetic constraints. Every gene that went into perfecting that massive frill and those formidable horns represents evolutionary investment that can't be reallocated to other survival traits. The dinosaurs have become victims of their own evolutionary success. The reproductive strategies that had served dinosaurs well for millions of years now accelerate their genetic doom. You watch the elaborate courtship displays of Parasaurolophus, those musical duck-billed dinosaurs, where only the males with the most perfect head crests and the most resonant calls win mating opportunities. This sexual selection, which had driven the evolution of increasingly spectacular adaptations, has also reduced genetic diversity by ensuring that only individuals with highly specific traits reproduce. The gene pool narrows with each generation, even as the population appears healthy. The specialized digestive systems that allowed different dinosaur species to exploit specific food sources become genetic death sentences in a world where those food sources are disappearing. You observe a diplodocus. Its massive neck evolved to reach the highest branches of ancient conifers, starving in a world where the trees it was designed to feed on are dead or dying. Its entire body plan, from the microscopic gut bacteria to the massive fermentation chambers in its abdomen, represents millions of years of genetic commitment to a lifestyle that no longer exists. Historians still argue whether genetic bottlenecks were a primary cause of dinosaur extinction or merely a contributing factor. But from your perspective, watching these creatures struggle with their own evolutionary heritage, the distinction is academic. You're witnessing the moment when genetic specialization, evolution's greatest triumph, becomes evolution's greatest liability. The immune system genetics of dinosaurs present a particularly tragic case study. You observe populations that had evolved resistance to specific pathogens, now facing entirely new disease pressures from the post-impact environment. Their immune systems, honed over millions of years to handle particular threats, lack the genetic diversity needed to respond to novel pathogens. A Tyrannosaurus rex, whose lineage had survived countless challenges, now dies from a bacterial infection that a more genetically diverse population might have resisted. The behavioral genetics that had created such sophisticated dinosaur societies now become prisons of instinct. You watch a group of Maiasaura, those good mother lizards, continuing to return to traditional nesting sites, even as those sites become death traps in the changed environment. Their genetic programming, refined over millions of years of successful reproduction, cannot adapt quickly enough to the new realities of a poisoned world. The instincts that had made them successful parents now ensure their offspring's doom. Most insidious aspect of this genetic bottleneck is how it interacts with the rapid environmental changes. You observe dinosaur populations that might have evolved solutions to single environmental pressures, failing when faced with multiple simultaneous challenges. Their genetic architecture, evolved for stability and optimization rather than flexibility, cannot reorganize quickly enough to handle the cascade of changes triggered by the asteroid impact and volcanic activity. The large body size that had been such an advantage for dinosaurs now represents a massive genetic burden. You watch the developmental genetics that control dinosaur growth, creating individuals that require years to reach reproductive maturity and decades to reach full size. In a world where rapid generation turnover is essential for evolutionary adaptation, the dinosaur's genetic commitment to large body size becomes a fatal liability. A mouse can evolve new traits in months. A dinosaur needs centuries. The specialized metabolic genetics of different dinosaur groups create additional constraints. You observe the highly specialized biochemistry of sauropods with their unique digestive systems and temperature regulation mechanisms, proving impossible to modify in response to changing environmental conditions. Their genetic investment in one particular metabolic strategy leaves them with no alternatives when that strategy stops working. The social genetics that had created complex dinosaur societies now work against survival. You watch genetically programmed flocking behaviors in hadrosaurs, facilitating the rapid spread of disease through populations. The genetic basis for their sophisticated social structures, from dominance hierarchies to cooperative breeding, becomes a liability when those structures cannot adapt to the breakdown of normal social conditions. The reproductive genetics present perhaps the most tragic example of evolutionary constraint. You observe dinosaur species with genetically determined breeding seasons that no longer sync with environmental conditions. Their reproductive cycles, controlled by genetic responses to temperature and day length, continue to follow ancient patterns even as the climate chaos makes successful reproduction impossible. They are genetically programmed to reproduce at times when their offspring cannot survive. As you witness this genetic tragedy unfold, you realize that the dinosaurs aren't just dying from external pressures, they're dying from the weight of their own evolutionary history. Every successful adaptation, every specialized feature, every refined behavior represents a genetic investment that cannot be liquidated when the environment changes. The dinosaurs have become too genetically committed to their own success to survive its failure, trapped in evolutionary amber of their own making. You're standing at the intersection of deep time and catastrophic change, watching the dinosaurs struggle not just with the current crisis, but with the cumulative effects of multiple extinction events that have been chipping away at their diversity for millions of years. The late Cretaceous extinction isn't the first rodeo for these creatures. It's the final act in a long tragedy that has been building for eons. You witness the last representatives of dinosaur lineages that had already been reduced to evolutionary remnants by earlier catastrophes, making the current crisis not just an extinction event, but the completion of a pattern that had been decades in the making. The Cenomanian-Turonian extinction event, roughly 94 million years ago, had already eliminated many marine reptile lineages and stressed terrestrial ecosystems in ways that never fully recovered. You observe the impoverished diversity of late Cretaceous marine reptiles compared to their early Cretaceous ancestors, whole families of mosasaurs, plesiosaurs, and marine crocodiles that had been lost to earlier oceanic catastrophes. The dinosaurs you're watching die aren't just facing their own extinction. They're the survivors of previous extinctions that had already reduced their resilience. The Aptian extinction, the Albian extinction, and several smaller events throughout the Cretaceous had been systematically reducing dinosaur diversity in ways that aren't obvious from the fossil record. You watch what appears to be a thriving ecosystem, but genetic analysis would reveal that many of these species are the last members of once diverse lineages. The Triceratops herds that seem so abundant represent just one surviving species from a ceratopsian family that had once included dozens of different forms. The apparent success of late Cretaceous dinosaurs masks a deeper pattern of evolutionary impoverishment. The cumulative effect of these multiple extinctions has been to reduce the genetic and ecological diversity that might have helped dinosaurs adapt to the current crisis. You observe ecosystems that look healthy on the surface, but lack the redundancy and flexibility that characterized earlier dinosaur communities. The elaborate food webs of the late Cretaceous, while impressive, are actually simplified versions of the more complex systems that had existed before previous extinction events stripped away layers of biological diversity. Historians still argue whether the pattern of multiple extinctions was leading inevitably to dinosaur doom, or whether the KPG event was truly the decisive factor. But from your perspective, watching these creatures struggle with challenges that would have been survivable for more diverse communities, the distinction is academic. You're witnessing the culmination of a long process of ecological degradation that had been weakening dinosaur resilience for millions of years. The island biogeography effects of previous extinctions have created what ecologists call the living dead, species that appear healthy but lack the genetic diversity and ecological support systems needed for long-term survival. You watch populations of Alamosaurus, those massive titanosaurs that represent the last survivors of sauropod lineages that had been much more diverse in earlier periods. Their apparent abundance masks the fact that they're essentially biological islands, isolated populations with limited genetic exchange and reduced evolutionary potential. The predator-prey relationships that had been destabilized by earlier extinctions create cascading vulnerabilities in the current crisis. You observe tyrannosaur populations that appear healthy, but are actually dependent on prey species that are themselves the survivors of previous extinctions. The loss of dietary diversity among herbivorous dinosaurs, caused by earlier plant extinctions, has created unstable food webs that collapse more easily under current pressures. The most insidious aspect of this extinction cascade is how it affects evolutionary innovation. You watch dinosaur lineages that had been experimenting with new body plans and ecological strategies during the mid-Cretaceous, now reverting to conservative survival strategies. The evolutionary experimentation that had driven dinosaur diversity for millions of years has been replaced by a focus on maintaining existing adaptations, reducing the likelihood that new solutions to environmental challenges will emerge. Marine ecosystems tell a particularly clear story of cumulative degradation. You observe the simplified marine reptile communities of the late Cretaceous, where a few highly specialized lineages have replaced the diverse communities that had existed earlier. The oceanic ecosystems that had supported dozens of different predator types now support only a handful, creating unstable food webs that are vulnerable to any additional stress. The plant communities that support terrestrial dinosaurs have also been affected by the cascade of extinctions. You watch ecosystems dominated by a few highly successful plant lineages, rather than the diverse communities that had existed earlier. The reduction in plant diversity has created simplified food webs that are more vulnerable to collapse when environmental conditions change. The dinosaurs aren't just facing current environmental challenges, they're facing them with reduced ecological support systems. The geographic patterns of previous extinctions have created what biogeographers call continental exhaustion, the gradual loss of regional diversity that reduces the pool of evolutionary innovation. You observe continents where dinosaur diversity has been gradually declining for millions of years, creating biogeographic patterns that make current survival even more difficult. The dinosaurs are fighting their final battle with an army that has already been decimated by previous conflicts. The final cruel irony is that the very success of the surviving dinosaur lineages has made them more vulnerable to the current crisis. You watch species that had succeeded by becoming increasingly specialized to fill the ecological niches left vacant by earlier extinctions. Their success has made them less adaptable to change, creating a pattern where each extinction event makes the survivors more vulnerable to the next one. As you witness this cascade of extinctions playing out over millions of years, you realize that the dinosaurs aren't just dying from the current catastrophe, they're dying from the accumulated weight of evolutionary history. Each previous extinction event has reduced their resilience, simplified their ecosystems, and narrowed their evolutionary options until the final catastrophe becomes not just possible, but inevitable. The KPG extinction isn't just an end, it's the completion of a pattern that had been building for eons. You're witnessing the last chapter of the dinosaur story, but it's not the ending you might expect. As the dust settles, literally, from the greatest extinction event in 66 million years, you watch the final survivors of the dinosaur lineages clinging to life in a world that has been fundamentally transformed. The massive herds of triceratops are gone. The thunderous footsteps of sauropods are silent, and the roars of tyrannosaurs no longer echo across the landscape. Yet life persists, and some of these survivors carry within them the genetic legacy that will eventually rule the skies of the future. The small theropods represent hope in the form of creatures no larger than chickens. You observe a group of early birds, descendants of velociraptors and other dromaeosaurs, picking through the ash-covered landscape with the focused intensity of professional survivors. Their feathers, originally evolved for display and temperature regulation, now serve as insulation against the nuclear winter conditions. These are the dinosaurs that will inherit the Earth, though they'll do so by abandoning almost everything that made their ancestors recognizable as dinosaurs. The marine environments tell their own story of selective survival. You watch the last of the marine reptiles, a few species of mosasaurs and plesiosaurs, struggling in the acidic, polluted oceans. Most will not survive the next few thousand years, but their ecological niches will eventually be filled by mammals that return to the sea. The age of marine reptiles is ending, but the age of whales and dolphins is still 10 million years in the future. The mammals that scurry through this post-apocalyptic landscape represent the future of large-bodied terrestrial life. You observe early ungulates, the ancestors of horses and elephants, beginning to explore the ecological niches left vacant by the dinosaurs' demise. Their success will be measured not in years, but in geological epochs, as they gradually evolve to fill the roles once occupied by dinosaurs. The irony is palpable. The meek have inherited the earth, but it will take them millions of years to become mighty. Historians still argue whether the survival of birds represents true dinosaur survival, or merely the survival of one highly modified dinosaur lineage. But from your perspective, watching these feathered survivors navigate their transformed world, the distinction is semantic. You're witnessing the moment when the dinosaur lineage splits into two evolutionary paths: extinction and radical transformation. The birds represent both the death of traditional dinosaurs and their ultimate survival in a form that would be unrecognizable to their ancestors. The plant communities that begin to recover from the extinction event provide clues about the future of terrestrial ecosystems. You watch ferns, those ancient survivors of previous mass extinctions, beginning to colonize the devastated landscapes. Their success will be temporary. Within a few million years, flowering plants will return to dominate terrestrial ecosystems. But for now, the world briefly resembles the more ancient landscapes of the Paleozoic era, a biological step backward that will eventually enable an evolutionary leap forward. The most remarkable aspect of this post-extinction world is its silence. You stand in landscapes that had echoed with the sounds of dinosaur communication for over 160 million years, the musical calls of hadrosaurs, the territorial roars of tyrannosaurs, the thunderous footsteps of sauropod herds. Now the dominant sounds are the whisper of wind through dead trees and the rustle of small survivors moving through the debris. The age of giants is over, and the age of subtlety has begun. The genetic legacy of the dinosaurs will persist in ways that won't be recognized for millions of years. You observe the early birds carrying within their genomes the developmental pathways that once created the elaborate crests of Parasaurolophus, the massive frills of Triceratops, and the powerful jaws of Tyrannosaurs. These genes, now dormant or repurposed, will occasionally surface in future evolution, creating echoes of the Mesozoic in the bodies of modern birds. The dinosaurs are gone, but their genetic shadow will fall across the future of life on Earth. The evolutionary innovations that had made dinosaurs successful, efficient respiratory systems, sophisticated reproductive strategies, complex social behaviors will be inherited by their survivors, and eventually by the mammals that replace them. You're witnessing not just the end of an era, but the transfer of evolutionary knowledge from one lineage to another. The dinosaur's legacy will live on in the flight of birds, the social structures of mammals, and the complex ecosystems of the future. The recovery process that begins in the aftermath of the extinction will take millions of years to complete. You watch the first tentative steps of ecosystem reconstruction as surviving plants and animals begin to explore the vacant ecological niches left by the dinosaurs' demise. The world will eventually become more diverse than it was during the Mesozoic era, but it will take 10 million years to achieve the level of complexity that was lost in the span of a few years. As you stand in this transformed world, you realize that extinction and survival are not opposites, but different aspects of the same evolutionary process. The dinosaurs have died, but their legacy lives on in the birds that will fill the skies, the mammals that will rule the land, and the complex ecosystems that will eventually emerge from the ashes of the Mesozoic era. The age of dinosaurs is over, but the age of life that they made possible is just beginning. The final lesson of the dinosaur extinction is that survival is not about being the strongest or the largest, but about being the most adaptable to change. The creatures that inherit the earth are not the mighty tyrannosaurs or the massive sauropods, but the small, flexible, generalized species that can survive when the rules of life itself are rewritten. The dinosaurs' greatest achievement was not their own success, but their role in creating the conditions that would allow life to continue and eventually flourish in forms they never could have imagined. Now, as our journey through deep time draws to close, let yourself sink deeper into the comfort of your bed, feeling the weight of 66 million years of history settling gently around you like a warm blanket. The stories of those magnificent creatures, the last Triceratops seeking shelter in a world gone cold, the final Tyrannosaurus rex stalking through dying forests, the small feathered survivors that would become the birds singing outside your window. These stories are now part of you, woven into the fabric of your dreams. The dinosaurs' extinction teaches us that change is the only constant in the universe, that even the mightiest rulers eventually pass away, leaving space for new forms of life to emerge and flourish. There's something deeply comforting about this cycle of death and renewal, this endless dance of evolution that has been playing out for billions of years and will continue long after we're gone. The same atoms that once formed the bones of Tyrannosaurus rex might now be part of the tree outside your window. The same carbon that once flowed through the blood of sauropods might now be part of the air you breathe. As you close your eyes and feel sleep beginning to wash over you, remember that you are part of this great story, a continuation of the same evolutionary line that produced those ancient giants. The birds that will greet tomorrow's dawn are living dinosaurs, carrying within their hollow bones and feathered wings the genetic legacy of the Mesozoic era. The mammals that scurry through our modern world are descendants of those tiny survivors who inherited the earth when the giants fell. Let the darkness behind your eyelids become the darkness of that ancient winter, but know that you're safe in your bed, separated from that catastrophe by the vast expanse of time. The extinction of the dinosaurs was not an ending, but a transformation, not a failure, but a passage from one chapter of Earth's story to another. And in that transformation, in that great turning of the wheel of time, there's a peace that transcends understanding, a rhythm that rocks the world to sleep and wakes it to new possibilities. Sleep now and dream of flying reptiles soaring through ancient skies, of massive herds moving across primordial landscapes, of the first flowers blooming in a world that was learning to be beautiful. Dream of survival and adaptation, of the endless creativity of life, finding new ways to flourish in the face of impossible odds. And when you wake, remember that you are part of this story, a brief but magnificent chapter in the ongoing saga of life on Earth. Sweet dreams, fellow travelers through time. The dinosaurs are gone, but their legacy lives on in every breath you take, every bird you see, every moment of wonder you experience in this amazing world we've inherited from them. Rest well, and let the ancient stories carry you gently into sleep.